Hey guys, today we're going to look at our similar triangles for day one. So what I want you to do is observe what I'm doing. So I'm going to take our smaller triangle and I'm going to map it onto the larger one. What do you notice about each of the three angles? So again, the first angle, the second angle, and the third angle with our dilation. So I want you to go over here and fill in what you know about angle A, angle B, and angle C. Now I want you to do the same thing and look at what you know about the sides. So our blue side, which is ED and AB, BC and EF, and AC and DF, assuming that these are our lengths for each. Okay, for the angles, you should have gotten AE is congruent to angle A is congruent to angle D. Angle B is congruent to angle E, and angle C is congruent to angle F. And for the sides, when we did constructions, we said that they were in proportion. So our blue side, which is AB of the left, over the blue side of the right triangle, is going to be congruent of the green segment AC over this green segment DF. And lastly, BC is going to be congruent to EF because our sides are in proportion. And to check it, AB is 6, DE is 2, AC is 10, DF is 5, BC is 8, EF is 4. And when you simplify each of them, 3, that should be a 3. Sorry, guys. You should get 2 is equal to 2, which is equal to 2. All of our sides are in proportion. So let's look at what similar triangles are. If corresponding angles are congruent and the ratio of the corresponding sides are in proportion, then it is said that the two figures are similar. And some properties and characteristics are that all three pairs of corresponding, all three pairs of corresponding angles are the same, all three pairs of corresponding sides are in the same proportion, and two pairs of sides in the same proportion, and that angle that is included is equal. Also, another one is that the cross products, when you set up that proportion, are equal. And we'll use the triangle down here. So 10 to 20, so that left side of the little over the left side of the big is equal to the bottom of the little over the bottom of the big. And when you multiply the cross products, they should be equal. So 10 times 14 is 140, is equal to 20 times 7, which is 140. Since their cross products are the same, those two triangles are similar, and we would go through all three sides to check and make sure. And the non-example would be 6 over 20 is equal to 12 over 10. And when we multiplied, 60 equal to 240, which is not true. Therefore, the cross products are not equal. Therefore, our triangles are not similar. So let's look at one example together. So given that STU, that symbol right there means similar, is similar to triangle VXT, what is the length of WV? So again, since we know that they're similar, we can set up a proportion to solve. So since we know our right side of the triangle, we're going to use that as our main proportion. We're trying to find WV, which is this segment here, so the corresponding piece would be 21. So let's set up a proportion. 21 over x, because we did the left side of the left triangle over the left side of the right triangle, is equal to the right side of the right triangle over the right side of the right triangle. And in order to solve this, we have a proportion we must cross multiply. So 28x is equal to 21 times 4, which is 84. And we want to divide by 28, and x is equal to 3. X is the value of WV, so we're done with that problem. WV is equal to 3. So I want you guys to try one. For this problem, it says, examine the two triangles seen in the problem. Circle yes or circle no to indicate whether the triangles are similar. Give a supporting reason as to why your answer is correct.